Hello everybody. Thank you for your time this afternoon. Welcome to our webinar called Timber Protection of Wood with Coatings. My name is Sarah Buckley from Abodo, and we make carefully crafted timber and from New Zealand grown timber. Our journey in making this timber has led us down the track of coatings because they are so integral to the finished product. And today we're lucky enough to have John Kilby from Resene to take us through a one-on-one on timber and timber coatings. Just before I hand over to John for an intro and the presentation, just a reminder, please keep yourselves on mute for the whole presentation. However, we would love to answer your questions, so please, any questions, type into the chat box and we can go through those at the end. If we've got time, we will answer a couple of questions. Any that we don't get to, we will collate and have John answer them, and we can follow those through with you afterwards. All right, John, please give us a bit of an intro on yourself and then jump right in to the presentation.
Thank you very much, Sarah, and welcome everybody. This is going to be a bit of fun and something interesting. Just very quickly, a background on myself. I've been in the coatings industry for over 39 years and specialise in corrosion of metal, concrete, and also timber. I also work for business development side of Resene Coatings Technologies, developing coatings specifically for the OEM timber market. So all my study and background is coatings related, and also coatings and linings through study through America and Australia and New Zealand, as well as basic chemistry and microbiology, concrete construction, pre-finished wood, timber flooring, wood science, and forensic investigation. So that's where we're at. So without further ado, it's important to understand a couple of things at this early part of this presentation. The purpose of this presentation is to overview the basics of wood and its structure and timber protection by use of coatings, during which we'll look into the performance and what to expect during the life of the coating. Now, this presentation is actually based on a full-day training course I run for Resene staff in New Zealand and Australia. So do understand that this is very, very basics, but it's important to understand the basics of timber or wood generically, so then you can understand the properties of what you're looking at when you go through your material selection process. So today is generic, it's basic, it's 101, and it'll be based on literally the pine tree, which is very common in New Zealand. And of course, Abodo uses that pine tree and then modifies it to make their products. So with that said, let's have a look at what we're going to look into today. And we're going to look inside the tree, and softwood versus hardwood, and heartwood versus sapwood, early wood versus late wood, cutting the log, timber and movement, cell penetration, why we actually coat timber in the first place, bare timber exposure, options to coat timber, effective angle of exposure, and paint and timber splitting, so we can get some understanding of that, and independent literature available. So let's get into it. Most importantly, that's a tree, and I'm not being smart, but I use this presentation for our staff as well. And what I'm trying to get across here is wood is natural, and every single tree is different, and every single piece of wood that comes from a tree is different. So that's what a tree looks like for you city folk. And the important thing to understand is we only use the trunk. So during the entire session today, this afternoon, this short session, remember timber is natural and it's going to act naturally. So let's have a wee look inside a tree. This is actually a pine tree, but anyway, we'll have a look inside. And the first bit we need to understand is the center bit, which is called the heartwood. And that is the core or the backbone of the tree. Now, trees grow out and up, and as the tree keeps on going out, all the new wood is on the outside. We'll talk about that in a minute. And the inside gets all gummed up and basically becomes stabilized and is not active in doing very much. So it's like the backbone of the tree, it's a lot denser. Then you have, it says it in the name, sapwood, which is the outer part of the tree. The newer part as it's growing out and up. And that's where all your saps are moving and your resins and rosins are moving up and down, and your water and all of that sort of stuff. So that's the newer part of the tree, and it's less dense than the core. And then, of course, the growth ring, we're going to talk those a bit more detail, but the growth ring between the dark bit and the light bit is 1 year. And so that's why you can count how old a tree is by chopping it in half, especially these sorts of trees, and counting the rings. And there is a difference. We're going to go into the details of the different parts of that growth ring shortly. And then you've got your cambium, which is the reproductive layer, and that's just under the bark. So if you've ever knocked some bark off a tree and you look there and it looks sort of soft and whitish and pastel-y, that's the part where it's the reproductive layer, where cells keep on building on themselves. And another layer within that is called phloem, and it's between the bark and the sapwood, and it acts as like a food and a growth hormone, etc. So there's a lot going on in that tree. And that's why anybody that's actually growing trees in your garden, whatever, and if they get ring barked or the bark damaged, an arborist will always try to repair it for you, because it's very important, because that's the growing part of the tree. So you need to. And then we have our friend bark, and of course that helps protect the inside of the tree, especially those fragile cells that are growing. It also helps reduce evaporation of water, so it helps contain everything on the inside, and it also protects those new cells from predators and etc. So. And you can see the bark's always cracked and split because it just keeps on going outwards and outwards in the tree. And then rays, it's not your cousin. It's rays are with timber, because it goes up and down, the tree grows up. The cells are all horizontal, going up and down the tree. But what you need to understand is there's these cells called rays, which go sideways through the tree, and they help move moisture or nutrients sideways through the tree. So there is some sideways movement in timber. And now we've got the pith, and that's that little, if you ever chop firewood, that's a little dark bit in the middle that holds a little bit of nutrient and doesn't do a heck of a lot. You're not interested in that. You don't want to see any pith in your timber. So there you go. There's inside the tree. Now let's look at some of those in more detail, because they do result in complications for you when you're using the timber in your building project. So the first one I really want to establish is a huge difference between a softwood and a hardwood, and except for the botanical difference you can see right in front of you, there are some unusual differences. In the olden days, a softwood was soft and a hardwood was hard, and it was just the boat builders, and we're talking the 1700s and 1800s and that. It was just how hard is the timber or how soft is the timber. The problem is today it's botanical and it's cellular, the definition between the difference. And as an example of that, balsa wood, if you ever make model aeroplanes or whatever, that's actually a hardwood. And Remu is technically a softwood. But the irony is balsa wood is soft and Remu's hard. So don't get all mixed up with it. It's botanical, but I'll make life a little bit easier for you. Here's the difference here. And on the right-hand side of your screen, that's a piece of Quila, or some people call it Merbau if you're in Australia. And on the left-hand side is just a simple cross-section of a pine tree. Now, the fundamental difference between these two is you can see the pine tree actually has growth rings. And again, you can see the dark and the light, and that's 1 year. But on the right-hand side, you can see all these little round dots, and they're called pores, which are very, very big pipe systems that go through the wood. And you can't see as many growth rings in there. But if you look very closely, what you can see is some lines going through here, dark ones and light ones, and dark ones and light ones. But they're not like these ones over here. What these actually are wet season and dry season. Whereas on the left-hand side with the pine tree, you've got your spring and then your summer, autumn growth in here, and then nothing happens in winter. So there's a little bit of a difference between hardwoods and softwoods with regard to what they look like. Now, I do want to teach you a little bit about heartwood and sapwood, because you will come across it. and it does make a difference to the density of any sort of timber, the hardness and penetration or adhesion of coatings, etc., etc. So again, remember that the heartwood is in the core of the tree. It's all gunged up with sap and goo and all of that, and there's nothing running up and down it. It's the really dense hard part of the tree. And then we have the sapwood, and that's the live part of the tree, and it's going, the sap's going up and down, etc., etc. And the reason I'm showing you this is, here's the picture, left-hand side, we've got some logs in the stack, and you've all seen that before, heartwood and sapwood, and there's some flooring, and you can see there's a color difference in that piece of timber between the light and the dark here. And some people like that because it's natural, and remember, timber's natural, and some people don't. Now, this is a photo of a complaint against Resene, and this is in the ceiling, and somebody's put this beautiful timber in the ceiling, and their complaint is, and they put some water-based polyurethane, some clear polyurethane on it, and their complaint is, look what your polyurethane did to my timber. And I'm looking at the photo with my jaw dropped thinking, well, there's some heartwood and some sapwood, and it's stuck in the middle of that ceiling, and the builder has put up this piece of timber, and here's another one, and butt jointed it to a beautiful piece of timber there, and the client's complaining that it's my fault. So if you had, and of course timber's expensive, but if the builder had actually put that right on the edge of the ceiling, you would never notice it. And if you've ever laid a wooden floor, you lay it out to make sure you get all the grains looking nicely, then you pick it up before you nail and glue it down, etc., etc. So there's an example of a piece of timber that's got some heartwood and some sapwood in it, and it looks very, very different. So just a trick for young players. Is that cool? And this is the most important one, and I'll go on about this quite a lot over the process of this presentation, including right at the end. Remember, we talked about early wood and late wood and the bands on the pine timber as it grows. And let's have a look. That's what the early wood looks like in the cell structure. It's growing, it grows in the springtime, and you know, as soon as springtime comes around, the grass goes crazy and everything just exponentially grows incredibly fast. And when that's happening, the cells are just big and open and quite like that. And you'll know what this is going to be, don't you? It's the late wood, which is, it grows in the summer and then the autumn, and then of course in the winter the tree sort of hibernates. It's a bit cold for it, so nothing happens. So just look at the size of those cells and understand there's a density difference between them. There will be a hardness difference between them. There will be a penetration difference between them of certain oils and stains that we're trying to use later. And the other thing is we've said that they're denser and harder, is if you bandsaw a piece of timber, it can look like that. And you've all seen it before, but sometimes some of you might not be sure what you're looking at, is the rough bits that stand up on the end are the early wood. And of course, the late wood's so dense, it doesn't get torn up. So you end up with those stripes. And we're going to talk about those later again when it comes to stain and the durability of stain. So just that piece of timber there's a massive difference between the early wood and late wood. And remember, it's natural timber. So cutting the log, and this is fascinating and it's interesting. We're trying to get squares and rectangles out of something that's circular. And if you've ever tried to do that, good luck, it's hard work. And we want to reduce the wastage on the log, especially beautiful logs, you know, I don't know, hardwood, all sorts of timbers. We want to reduce the waste. So we end up cutting all these different shapes out, and how it gets cut depends a lot on the performance of the timber once it's on your building. So let's just have a wee look at that. So if you have a log, example, this is a pine tree, we want to get as much as possible out. So the most efficient way to do that is plane saw it, and you just cut it and cut it and cut it just into stripes like the picture on your screen. Now the key, we'll go through another slide shortly to overview this again, but if you look at the end grain and you start seeing the smiley faces down the bottom and the sad face at the top, and then the vertical lines in the middle. So that's going to depend on how that timber moves and how stable it is. But again, that's the most efficient way of cutting a log. You get the most bang for your buck. Then if you want timber to be a little bit more stable, so you have just those stripes grain at the end of the timber, you quarter saw it, whereas you basically can cut the log up into quarters and then chop those pieces out to get that nice stable timber. And then another way, a slightly more efficient one, is what's called quarter and rift sawn. And again, we're going to go through that in a minute. Is you can see you get a lot more efficiency. So this one's not very, this is most efficient, that's not very efficient, and that's much better. You still get a lot of wastage, and if you order quarter or rift sawn timber, which sometimes you can from some suppliers, to get the stability out of it, it will cost you a lot more. But you just got to understand that you're paying for wastage. And no different to if you ever bought glass before, you pay for the wastage when they cut it out of the sheet. So let's have a look in a little bit more detail on our log. And if we chop this piece out and we get a plank of wood or profile of wood, whatever you want to call it, if you look on the end, you get that nice curve going on, and then down the side you get the stripes, and on top of it you get this these curves, and we call it the cathedral effect. That's what's called a flat or half sawn timber profile. And of all the timber profiles, when that gets wet and dries, it's going to move the most. So we're going to call that the most unstable cut of timber. If you cut a bit out of this bit, you end up getting the grain going at a slight angle on the end, as you can see, and then up the side you get those stripes, and then on top you get those stripes. And that's called rift sawn. It's a reasonably stable piece of timber. That particular piece of timber, if you've got some nice wood, is often used by furniture makers or cabinet makers. And when you think about it, the reason they like it for making legs on a table or something is all four sides, you get the straight up and down grain. So just saying, it's very, very popular with those sorts of people. It's reasonably stable. I like it. And my favorite is quarter sawn. And quarter sawn, you see the growth rings basically up and down at the end and striped along the top, and you only get the cathedral effect down the side. It's no big deal on that. And that's, as far as I'm concerned, between half sawn and quarter sawn for today's presentation. Quarter sawn is, regardless on timber and that, is always more stable and will make sense in a minute. So that's sort of thing what you're looking at. Again, remember, this is 101 of timber. So there you go. Just very, very quickly, this is a rusticated weatherboard profile, and that's a capillary break, and they're quite important because as moisture creeps up behind the weatherboard, it just helps to break the capillary action. So if you've ever wondered what they are, and when you put the weatherboards on the house, the builder lines those up with a template, so the builder can get them all in line, so it works well. And then sometimes you see those little unusual grooves on the back of the board. They are what we call stress relief grooves to help reduce the stress in the timber when it's moving, to help relieve some of that. And we're going to talk about the rusticated profile later in the session to show you some pros and cons with it. This is a bevel back, and if you compare this, and I'm just talking my favorite profiles, and it's all design and personal choice. The reason I like the bevel back is if you look at the end, there's a lot of meat in it. There's a lot of uniformity in the thickness, whereas the rusticated board is thin and thick and thin. And when you get movement stresses and that sort of thing, it does make a difference to the stability of the board. That being said, you can get more stable timbers, and Abodo can talk to you about that, etc., etc. But remember, today's just generic. And there's reasons for these different designs, but my favorite is the bevel back. It's simple, very, very, very simple indeed. And then don't forget, it's a single nail per board. I was at a presentation once in Wellington, and a whole lot of builders and architects were at it, and I happened to be the only paint guy there because I was interested in the timber. And I've been doing timber for about 23 years now, so I've had to study it and understand it so I can understand how coatings work, etc., etc. Anyway, one of the presentations was somebody says you only put a single nail in a weatherboard, and the whole audience went ooh ah, and had never heard of that before. And the irony is the weatherboards pivot as they move in the seasons, and they need to be able to move. And if you put two nails in, it stops it from moving. And what will happen is all the stress builds up, goes to the nail, and the board just splits along that line. So it's important that when you have these weatherboards, you get the design information from the supplier, and they will tell you where and when to put that nail and how to fix them. So it's a very, very important part of the building process. And this is, I don't know much about this, it's called a splay cut, very, very similar to the bevel back. It's just more tapered along the entire length rather than just a little bit at the top. So of those, you can just see the ones with a bit more meat, they're just that little bit more stable. And when I'm talking about stable, I'm talking about over the life of 10, 15, 20 years. We get all different seasons. We get hot summers, cold summers, wet winters, dry winters. So once you put the weatherboards up, you want them to stay there a long time. You want them looking good. So it's worth considering and talking to your weatherboard suppliers and all of that about what profiles are better and how do I get more stability out of the timber. And we're going to talk about stability in a sec with regard to timber movement. So there you go. There's the slide, timber and movement. Remember, timber's natural. So here's a log, and let's have a look again at some timber movement. So just remember, this is made up of cells. Timber is made up of a whole lot of cells. Now, they're not little round ones like humans. They're longitudinal like tubes. But like the sponge on your kitchen sink, if it gets wet, what does it do? Expand. And when it dries, it shrinks. So you just got to remember timber is expanding, contracting, different moisture content, different times of year, rains for a month or a week or 2 days, and it's sunshine for 5 days. So if it gets wet, it moves out. If it dries, it shrinks. Now, this is what we call your flat sawn or half sawn profile, and it's a tangential cut. And movement or expansion or shrinkage is greatest along the growth rings. So if you look at the end of that board and you can see the growth rings are going this way, your expansion contraction is going to be widthwise. You might have seen your grandparents doing some building or whatever, or a carpenter, and you'll see them look at the end grain of the timber. What they're looking for is to see what sort of profile it is to figure out which way to use it or which one's going to be more stable. So here is your quarter sawn board or your radial cut, and you can see here that movement is least across the growth rings. So expansion contraction is least across. It's going to go vary in thickness there, but we don't worry about that too much compared to the tangential cut, which is your half sawn, which moves this way. And again, I've got some photos for you in a second to show you how much that is of concern. All right. So, and contrary to popular belief, the tree's grown that way. The cells are almost set in stone, excuse it, pun. They're not going to move lengthwise very much. It's not like metal, like bridges or railway tracks where they have those expansion joints and it moves that way. Timber doesn't. Timber moves widthwise. Well, again, when you look at the flat sawn along the growth rings. And here's an example, and this is from a brand's timber cladding guide. And so this is generic, nothing to do with me, but I'm just putting it up there to show you some comparisons. And this is based on some movement, and it's based on a moisture content movement of 6%. So from 18% moisture content down to 12% moisture content, and if the board was 200 millimeters wide. And you can see at the top, you've got radiata pine and radial, which, if you remember, look up the top there, it's the quarter sawn, will move 1.4 millimeters in width. But tangential, it will move, which is your half sawn, it will move 3.1 millimeters. And that's a lot. It's that much. You can see it with your eyes, no problem at all. And as you go down, you can see, let's see down right at the bottom, we've got, as an example, and this is just from their book, Western red cedar imported. Your radial cut will be 0.8 millimeters and your tangential will be 1.7. So when people say that cedar is more stable than pine, that's what they're meaning and that's what they're referring to. What's interesting here is if you look at that chart one up, it goes Western red cedar, New Zealand. So cedar, the type of cedar grown in New Zealand, instead of 0.8 for the radial cut, it will move 1.4. And the tangential cut, instead of 1.7, will move 2.2. And you're thinking to yourself, what's the difference there? Well, this is an opportunity to tell you that if you grow trees in different locations, in different environments, even if it's a similar species or the same species, the result will be different in the timber that you actually get. And that's really important to understand, even within a forest. And we've got a lot of hilly forests, up in Taupo and et cetera, and Rotorua and all that, is if you have a tree growing on top of a hill, and then a tree growing in a valley, and then a tree growing in the shaded side of a valley, and a tree growing on the windy side of a valley, even though they're all the same tree from the same nursery, they will all give you different resulting wood, right? Remember, it's natural. So, but we can work with that. It's just a matter of what I'm trying to do today is not give you any surprises, or at the end of today, you'll start understanding why you hear about engineered timber and modified timber, etc. What they're doing is they're taking a fast-growing species, which is great for carbon absorption, by the way. It's like this massive sink of carbon dioxide. How do we make them more stable and usable? And that's where we do the thermally modified timber, etc., etc. So I'll leave Abodo to discuss that with you. But now we're starting to understand why you want to do these sorts of things. So that's just fascinating. And the other thing you need to understand is timber's moisture content varies during the year. And as an example, we're just using pine as an example. We're not picking on pine, because this is the data I have, and there's a lot of data on pine. It can vary between 11 and 18% summer to winter. So what I mean is this timber absorbs moisture and it desorbs moisture seasonally, monthly, weekly, whatever, but that's what happens with timber. So let's have a look. And here's another chart from one of the brand's literatures, and let's have a look there's a summer EMC and winter EMC, and that's just equilibrium moisture content averages. And again, what you'll see is, as an example only, but in Auckland, which is a subtropical climate, in the summer it might be down to 13% and winter is up to 19%. So you've just seen a 6% change in moisture content between the seasons. So do you think the timber is going to move? Of course it is. And that's why we put the single nail in. We're going to allow for that movement, etc., etc. Now, if we look at Dunedin, and I know Dunedin quite well because when I was younger, I grew up there. I'm based in Wellington now, but when I grew up there, and you can see, just as on average, by the way, that there's not much of a change. So you're not going to get as much timber movement as in Auckland. Now, can you imagine if you had a house with weatherboards on and you grew up in Dunedin and you go, weatherboards are great, they don't move very much, and then you suddenly get a promotion and go to Auckland or whatever, and you buy another weatherboard house, do it exactly the same as you did in Dunedin, and it moves all over the place. And you go, what's wrong with your paint? What's wrong with your weatherboard? And it's like, well, you're in a different climate, because Dunedin, I always like to joke that Dunedin's Antarctic, but it's not. It's temperate, but Auckland is subtropical. So there's those two environments in New Zealand. You've got alpine up in Central Otago and Queenstown, and then you've got volcanic or geothermal in the middle of the island. So New Zealand is really, really mixed up with so many environments that we're going to allow for. But that's just a really, really good chart. And check out Alexandra, and this is a classic 10 to 19.5. And again, I don't make these figures up. I just took it from the book. A lot of people, and the reason that's there, especially when I'm teaching my staff, is a lot of people that grow up in Dunedin and get old and retire, guess where they move to? Central Otago. And so again, they might have 4 weatherboard houses in Dunedin over the time of growing up, and then suddenly they move to Alexandra. and wonder why their boards are moving more than in Dunedin. So again, it's just very interesting stuff. But once you understand timber a lot more, then you can work around it and you allow for it. And this is a classic. Yes.
Sorry, just it was just interesting seeing the difference between Invercargill and Alexandra when they don't seem too far away. Between Auckland and Northland, is there a big difference? Auckland's subtropical, as you said, but Northland feels like it is more so.
So the further up you get, so it's really simple. And I'm not going to joke about Northland because they've had a really rough time lately. So at the moment, they've had a lot of rain and it will be horrific up there. But being just absolutely, I deal with environments all the time with the corrosion of metals, right? Is the closer you get to the equator, the more tropical it's going to get. And basically that means you're going to have a higher humidity, which is a higher moisture content, which is more moisture available to absorb. We're talking vapor, by the way, we're not talking liquid here, but just vapor naturally absorbs into it. So Northland would just be very, very similar to Auckland, if not just this little bit worse. Okay. In fairness, the reason Invercargill will be slightly higher is because even in summer, it's going to be slightly wetter in Invercargill compared to Resene. So, but again, this is just data from the brand's book, but it's just a really good example. The reason I use it is to try to re-emphasize. Can you imagine the west coast of the South Island is going to be totally different to the east coast? So Christchurch is going to be totally different to Greymouth or something like that. So
no, it's very interesting. It's a conversation we have with clients all the time. Is the environment, specific environment, makes a big difference.
Yep. And you can be watching this slideshow and go, oh, well, I'll just make it out of metal. Well, I'm sorry, but environments closer to the sea make a massive difference to the corrosion of that metal versus Citra Otago. So, and then they have a density difference. There are so many different, and okay, well, that I'll go for cement board. Well, that has its own implications and issues as well. So all I'm just saying is it's important that you understand what you're dealing with and work on it from there. But it's natural, it's going to move. You just got to allow it to move, and that's all comes into the design. But this is a classic. This picture is from a house that was painted white for 60 years, and then somebody decided, from a fashion point of view, to paint it a dark color. And of course, within a short period of time, now dark colors, we're not going to get into it too much, but they absorb a lot more infrared spectrum, which is your heat generating part of the sun's rays. And all that does is dry them out. So it just dries it out faster than its normal movement. So that would have done that in the middle of summer, but it's just dried it out more so than normal equilibrium moisture contents. And of course, it moved like crazy. And in this case, as an example, there's a 1% movement for every 3% change in moisture content below 30%. So just say this was actually in Wellington, but just this example, as if it was in Auckland, that would mean 140 millimeter wide board would shrink 2.8 millimeters. So you think about it, you know, all those old villas and buildings and all of that in the olden days from the 1900s and 1800s, they had really, really massive weatherboards. Why do you think weatherboards have got shorter? Because its moisture is a percentage movement. So the thinner the board, the less it moves. Just do the math. So, and this is a bane of my life, is when somebody decides to come along and put sealant in all of those joints because it looks nice, or I don't want gaps for where spiders can live, or there's all sorts of excuses for it. The catch-22 is when that board moves, and if it shrinks, it's going to pull the sealant with it, and you get this tearing like that, and it's terrible. What's more important to everybody watching today is brands says don't do it. And the reason brand says don't do it is they like, in a windy day, when those boards are moving just a little bit, air pressure can push up behind there, and it helps aerate, and it helps keep your building dry in the cavity behind. So it's not necessarily a bad thing to have those gaps, right? But just if I can get one thing across, please don't gap your weatherboards with sealants and all of that sort of stuff. Let them breathe. They're meant to breathe. And I'm not going to bore you with this, but I just want to put it down to the bottom here. Timber can move. And it can move in all those different shapes that you're seeing on your screen, bows and cups and crooks and kinks and warps. And I don't like using the word deformity. I just call it change in the shape of wood, but let's argue it's generally caused by different changes in moisture content within the profile. So you can have the outer surface wetter and the inner surface drier on a weatherboard, and of course it's going to cup or move depending on that. And the most important thing to understand is when they are processing the timber and drying it in the kilns and all of that, they have to do it at a certain speed to make sure they reduce that. But certain grain structure within the, remember, every tree is different. The odd piece is going to get a bit wonky on you, and that gets put into the lower grade pile or firewood or etc. etc. But timber can do all of these things. And again, when you saw me talking about how I love quarter sawn, or I kept on saying quarter sawn is more stable than the half sawn, not being biased, I'm just saying it is what it is. Well, you're going to get a lot less cupping with a quarter sawn board than you will with a flat sawn board. It's just fact. So it's just interesting to know what you're looking at. Kinks are really interesting. It's when the board can be straight and then the end of it sort of kinks down, and often it's to do with the drying of the board, but sometimes there's a defect in the grain left over from where a branch came out or something like that, and it's just naturally popping that way and following its own grain lines. So you can often see that on a piece of timber, and sometimes it can happen years later. So it's just it's timber. It's fascinating. And here's a neat picture. That's another way of looking at timber movement. So you can see it shrunk along the grain. So the sides are getting a little bit thinner. And this one is not a very happy piece of timber. And that's the way it shapes itself. That's cupping. And then diamondings is you get shrinkage from both sides. And so it's equal, so you end up with a diamond shape. Have you ever seen the odd bit of timber leg on a furniture, then say I made a pine or something, and then the leg twists on you, and that's what causes that. This is just going to be careful. And radial cut, its thickness is done like that, but dimensionally it's quite good. So that's just another picture I'm showing you. I like pictures; they're very educational. So I've just thrown these in because you shouldn't see these, but you've heard when you're in the timber industry chopping up logs, you hear things called shakes, and it's a stress and a crack within the log itself, and this is little cup shakes. If you've ever seen that before, it's interesting. Here's one for you, a radial shake, and it's to do with stresses on the log when they chop them down and they smash into other things. It can cause stresses, and also from drying unevenly and all these sorts of things. And you see that split there. Well, I've seen that happen in a piece of timber straight away, and I've seen it happen 4 years later. So there you go. It's just stresses in the timber. It can do that. It's not a fault of the timber. It's just what timber can do, etc., etc. Engineered wood helps get rid of all that in the process of doing it. So today's hopefully just education and just the tip of the iceberg. Don't forget, you can type all of this stuff into Google. There's great learning resources out there. Abodo's got them as well. So just keep it up. And this is something I want to get across because there's a misunderstanding about timber cell penetration when it comes to oils and stains, all right? So whether it's a stain or a paint or whatever, we're just going to call it polymer. And polymers are very large molecules, and they don't diffuse through cell walls very, 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 very well. Let me get some pictures up for you. This sort of thing. So waterborne or solvent-borne, but if they're polymers like your acrylics and those type of materials, they're very, very, very large molecular chain. Now your oils or your oil-based coatings are a lot smaller molecular chain. So just think of it as if you're trying to get into cells, they're closed. So you need to break them open, and sometimes that's done mechanically or with weathering, etc. And if you have a big long snake trying to wiggle in all of those areas, it's not going to go very far. Anybody that's done caving knows that the short, skinny people get through the caves in those hard to get areas a lot better than tall people, as an example. So just understand that you don't get as much cell penetration with all these stains as what you think you do. And I can show you some examples of that shortly. So it's to do with the polymer size and also how long they stay wet. And here's an example, and I'm just showing you this as an example because it helps show the cell structure of timber. There's a brand new piece of timber. This is cedar for this example. And then this is a close-up picture of after 6-9 months outside. And you can see the longitudinal cells. Some of them are broken open, some of them are gummed up. It's just a really good picture, which I use for my students to just show them the elongation of the wood cells. It's just an example. But that's also what weathering does to timber, which we'll spend a bit more time on there. Now, what I'm about to show you is for educational purposes only, and it's to try to show the difference or the penetration ability, potential ability of stains and oils in the market. Common ones, which I'll explain in a minute, and I use this to demonstrate to our staff. So what I've done is I get a piece of filter paper and I put on a X quantity of our waterborne wood stain. And the whole idea is I drop it onto the paper, and then the paper's made out of cellulose fibers. And so the whole idea is it spreads out, and then we see how far it spreads out and we compare it to the other ones, right? So here's our waterborne stain, and it's a certain color. I put some yellow oxide paint pigments in it, and it's a certain color. And as you can see, if you just keep your eyes on it, it's spread out, and the pigments are the colored pigments are very heavy, so they stay in the middle, and the paper's warped a bit. That's why it's that funny shape. Sorry about that, waterborne coatings. And then you can see the orangey yellow stuff. That's actually the tint base, and those orange and yellow are little microscopic, what we call transmetal pigments, which help absorb ultraviolet, and ultraviolet is what damages the timber. I'll show you some photos shortly. And then right on the edge is some clear, and that's your oil. There's a little bit of oil in there, and so you can see that penetrates the most. Now, if we compare that to the next picture, which is actually technically the same color, but because it's oil-based versus the one on the left that's water-based, the light refracts differently within the oil, and it looks a darker color, but technically they're the same color. Okay. Now you can see what happens here is it's the filter paper. I drop the same amount in the middle, and it spreads out and drops off the heavy tinters, keeps on spreading out, and then on the lighter brown area, that's your oils and further penetration. And then if you strain your eyes really hard, you can see on the outer edge there's a sort of a clear watery mark sort of look. That's actually the oil. So you can see that the oil-based is a smaller particle, so it spreads further, but also oil-based stains take longer to dry, and it can only penetrate when it's wet. So on the left-hand side, everybody's in a hurry, and they use the waterborne stains. And while they do penetrate, they can only penetrate when they're wet. So if they dry like in half an hour, you only get half an hour's worth of potential penetration, and a little bit of oil left over keeps on going back. Anyway, the oil-based stains, they penetrate a lot further. They're smaller molecules, so they squeeze into those broken cells, so you get a little bit more penetration. And then the last one, for demonstration purposes, is a mineral oil, a colored mineral oil, and these never dry. And they're very, very, very small molecules. They're based on mineral oils, which are petrochemical based. However, they penetrate and penetrate and penetrate. Now, I didn't have the same color, so this is a red oxide, but it's a similar weight pigment and similar size. So for the purpose of this test, it's fine. So I drop it in the middle, starts to spread out, and then you can see actually right around the edge of that paper, it goes off the edge. That's all the clear oil. So of them, when we want stains, you know, your wood stains for outside, we want the smallest molecule possible, the longest drying time, I'm just saying, and we get the better penetration, which helps stabilize the cell. Now, the cells in timber will still take up moisture, but it just takes them longer to take up moisture if we get a little bit of those sorts of oils in there. And then we can get, there's a classic here, I'll just say it, is Abodo stain. Their stain is what we call a penetrating oil stain that's waterborne. So you emulsified it. So it is actually an oil stain, but it's emulsified in water. So you don't have to have all those solvents coming off. And that's more like the middle one in there. So it's cool and it does dry. So just as an example. So we're trying to get the best of both worlds. Again, example only, but it's great to see this sort of comparison. So remember, we chopped down the tree and here's our log with the, the heartwood and sapwood and some bark and some stuff like that. And unfortunately, we've taken the bark off, and the bark, remember, protects the tree and all of that sort of stuff. And we've exposed the inside of the tree to the outside world, and nature never intended the inside of the tree to be seen by the outside world. Okay, so what we need to do is help protect it from the environment. So we oil it, stain it, or paint it, and we're almost there. We're getting to the fun part now, so we'll learn a bit about that. So with the coating options, and this is important, these are options. I'm not recommending you follow them. I'm just saying, what options are we going to talk about today? Well, you could do nothing, and don't forget that's always an option. You could oil it with a vegetable-based oil, clear or colored. You could oil it with a mineral-based oil, clear or colored. You could stain it with a penetrating stain. You could stain it with a film-forming stain. You could polyurethane it with a clear coating, or you could paint it. Now, I'm not going to agree or disagree with all those options. I'm just saying it's important that you understand, and we discuss those options today so you can make more informed decisions. So let's move. So what are we trying to do? Just had a glitch on my computer then, but all's fine, don't panic. So what we're trying to do is, reduce mold and silvering and reduce warping and get some stability in the timber and reduce UV damage and the nail popping and the cupping and all of that. So this is what we're trying to do. And so let's see how we can do that. So I just think it's important just to say this a little bit for you. It's important to understand each option has its pros and cons, and it's up to the customer, owner, specifier, or whoever to fully understand these properties and what option they choose. And that's what I'm going to try to offer you right here, right now. So if we do nothing, it's really simple. Here's 2 bits of timber that I stuck outside and just left them to nothing. So there's a couple of things that are really important here. Ultraviolet light breaks down the lignin part of the cell structure of the timber and breaks it open, which then starts allowing the timber to open up more. You get more moisture, it's easier to get in. The more moisture goes in, you get a bit more expansion, contraction, which leads to cracking and splitting and all of that sort of stuff. So, and you'll see the grey, and it's important to understand this too. All the things that are inside, there's these little pigment things or parts of timber which make up the colour. They're water soluble. So they get washed out by the weather. So that's why your timber goes grey. And you can see with those little black darker stains starting to show up in there. Well, that's your mold. And mold eats the carbohydrate sugars that are brought to the surface by the water. And it's just nature. Mold is natural. So that's what it does. So if we do nothing, that's what you could expect. Now, I'm not sure in your area what your local council says, but in a lot of cases the building code starts to say that you're not allowed to do nothing, you've got to do something. So I'll leave you guys to argue that one out, but I'm just saying that's what happens if you do nothing. All right, and some people like the natural look, but you get more cracking and checking, etc., etc. Now the next one is oil it with a vegetable oil, clear or semi colored. Now people oil a timber and think that they're keeping it alive, and you say we're feeding the timber, etc. All you're doing is feeding mold, right? So oil can help give it a deeper glow and bring out the natural colors of the timber, but vegetable oils, and what we mean by that is they're based on plants, linseed oil, rapeseed oil, flaxseed oil, etc. They can act as feedstock for molds. And so to try to overcome this, we fill them full of fungicides and moldicides. So let's do something natural and then put a whole lot of poisons in it. So it's not the smartest move, especially for outside. For inside, it's a different environment. But outside, so these oils are also dry by oxidation. So over time, they lose their flexibility. And as the wood moves, they can still split and crack and open up. So it's not the smartest move, and they will turn black pretty quick outside. So here's an example, and this is just one piece of pine timber along the length, and then down the side I put some stripes, and on the left hand side, top to bottom is 1 month, 2 months, 3 months. Then I put some mineral oil, and then I put some Danske teak oil, which is much highly processed vegetable oils, and then I put raw linseed oil. And you can see down the bottom there, that's the weather, which we had dry and wet cycles, etc., etc. And you can just see that the timber grew mold, as you would expect. The mineral oil, it grew less mold because the oil is petrochemical based, so it doesn't act as a feedstock for the food. Then you've got Danske teak oil. Now, the more you process a vegetable oil, the less food it is. A little bit difference between fast food and grandma's Sunday lunch. So the Danske teak oil is like your processed food, and then your raw linseed oil is like grandma's lunch, and you can see the difference in the nutrient value there. So again, I just use it as a learning tool. We have to put moldicides and fungicides in to reduce the mold spore growth. Remember, mold is everywhere, and timber is full of sugars or carbohydrates, and they help feed the mold growth. So it's just an example of why I don't like using natural oils outside. Inside, you've got a drier environment, and it's a totally different kettle of fish. All right? And here's an example of, some of you might remember years ago, everybody started going down the soybean oil, it's going to save the planet, etc., etc. And these are some tests that were done. The blackness in that grey is just mold growing. And again, the irony is the testing on this was, let's just put a whole lot of moldicides and fungicides on it. And it's like, well, aren't you defeating the purpose? So I'm just saying that we need to really, really modify these oils to reduce their feedstock ability for molds. And that's where your stains and that come into it. So now you could oil it with a mineral oil, clear or coloured. And these are your direct petrochemical based. By the way, acrylic resins and all of that, they're all made out of petrochemical based materials too. So just saying. So mineral oils, they're petrochemical based. They are very, very, very small molecules, and they never dry. So the advantage is they help penetrate into the cell wall structure and stabilize the timber by just making it harder for moisture to absorb into those areas. So it just helps reduce that amount of movement in there. And you can use it clear or tinted, which is some nice colors to try and replace the color of the timber that nature washed away. We put a very small amount of resin, and that helps glue the pigments onto the timber. And that's what it looks like. There's some our product we make, and then there's the other brand, and it's as good as gold. It's just an example to show, but that will wear off in 1 or 2 years, and I'll show you some more photos in a minute. And it does need regular maintenance, all right? But you get the natural look. That's what your colored mineral oils do. I don't like calling them stains because they look like a stain, but they're a mineral oil. The only issue is when you put them on, you're sort of stuck with it because you can't paint over the top of them years later because there could be still mineral oil in the wood, and it could make the paint come off, and it's difficult to stain over them as well. So once you make this decision, you sort of commit to it, and you do the regular maintenance, and it looks great. It's an opinion. Now you could stain it with a penetrating stain, and these are your more natural looking stains, and they're very, very popular. Now the penetrating stain is designed to penetrate as much as it can, as much as the cell structure can, and again to get into the outer layer of the timber cell that's on the top of the surface. And again, they require regular maintenance, especially on the weathered side, probably every couple of years. But they're designed to erode away, so it makes recoating very, very easy. There's no flaking or peeling, they just erode away, and you clean them up and put more on. As long as you can gain access to it, then that's not a problem. But if it's a 5-story building, it's a little bit different. So the following I'm going to show you is the same for mineral oils or penetrating stains. So just keep that in mind. And this is an example from brands on the erosion or penetrating stains. And basically, again, we do it so that they don't flake or peel, so that the preparation is a lot easier. and but as long as you've got access to it, then it's not a problem. And you've got to weigh up, is if I paint it and it lasts 10 years and then I've got to do all that, get rid of any potential flaking and blah, 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 versus just give it a clean and whack another coat on, you've got to start weighing those things up, right? So here's a dressed piece of timber and here's a bandsawn piece of timber, 1 and 2 coats. The top bit was covered up and they're exposed. Now you can see that if you open up the timber surface bandsaw, you get a lot more penetration, a lot more durability, and it looks great. So a lot of people like the smooth dressed timber, but that's sealed smooth, and it's harder for any sort of stain to get penetration, and it doesn't last as long. So you can get some really, really fine bandsawed finish now, and it just gives you more durability on the stain. It looks great. And remember when we told you that I showed you that photo of early wood and late wood, and you can see some of it's more porous than others. And remember that the early wood is opened up from the bandsaw, and the late wood's got that hard surface where the stain doesn't penetrate. Well, here's an example of the north face and west face, or north face, where you've got some half sawn timber and the late wood bands are there, and the stain's just eroded off because wind and that had dust in it and it's just eroded away. That's natural and it's normal. My suggestion is you don't put half sawn timber on the north face of a building in the southern hemisphere. But that is natural and that's what it does.
So this is going back, just to clarify, John, go back to your earlier slide showing the cut of the log, isn't it, between the flat sawn, your rift sawn and your quarter sawn.
The half sawn and the quarter sawn. The half sawn, remember how the grain goes. The plane on it is you're going to end up, I'll just go, remember when we bandsawed it, that early wood is open cells and they tear out very nicely with the bandsaw when it goes across it, but the late wood cells are very dense and they don't open up. So if you're staining it, let's go back to the pictures, if you're staining it, you'll get good penetration into the big cells that are opened up, but you won't get penetration into the late wood bands, and then it erodes off and you get this pattern, as you can see there. Now that's absolutely normal, but I'm just saying that if you were going to put weatherboards on a house, why wouldn't you put the quarter sawn ones on the north face so you don't get that problem? That's all I'm trying to explain here. So, because remember, it's natural. So, and this is a classic, left-hand side quarter sawn, right-hand side flat sawn. And again, you can see the late wood bands and the early wood bands. The late wood bands in this are a lot lighter, okay, and because the stain hasn't penetrated as much, and you put those side by side and then somebody complains it's the wrong color, that's actually the same color. And because stains, remember, are semi-transparent, so you get some of the light going through and you get the color differential. So here's another classic. The top bit's a light piece of timber and the bottom bit's a dark piece of timber. That's actually the same color stain. Until it silvers off with the weathering behind it, you'll get that color difference, and then eventually it will even itself out. But that's what you can get. Here's a classic, and again, stains are semi-transparent because we want the natural, want it to look natural. That's why they're semi-transparent, but that means some UV can go through, breaks down the cell structure, and then they erode away. But if you are putting the stain on unevenly and you get lap marks, see the bottom right-hand side, you get lap marks. Of course, you're going to have twice as much stain on the lap mark and not as much stain on the other area. So you get these dark and light patches. So it's really important the painters know that they have to go the whole length of the board to keep it nice and even. But that's what their job is. So it's not overly hard. And this is a classic. That's dressed and that's bandsawn. And that just shows you the difference in the absorption. And if you absorb more, you're going to get more color on the surface. So you get that really fundamental difference in there. Dressed and bandsawn, I know it was a design feature, but expect it to look differently. And on the right-hand side was a piece of plywood, and the plywood is peeled. So you still get the early wood and late wood bands, which is different density. And you can see there that they used an oil-based stain on there, and it didn't penetrate the late wood, so it's shinier. In the early wood, it penetrated further, so it's duller, and they didn't like that look. So you've got to understand the timber and what you're looking at, and it's natural, and that's what you get. So it's important from a design point of view just to understand what you're looking at when you're looking at that. I won't bother reading all those words. I just want to show you something. But this is your older style stains. They're called film forming stains. Now, in the 70s and 80s and even 90s or early 90s, these were the only penetrating stains weren't around in the New Zealand market. Your stains were what we call film forming. A classic, I can say it because they're not around anymore, is some of you that have been in the industry a long time will understand Gold XDNF11, British Paint's timber stain. We're talking from the 80s and that. But they were film forming and they sat on top of the timber. Now, they actually last longer, 4 or 5 years, before you had to restain them rather than a couple of years on your north face. But they didn't erode away. And as the UV goes through, breaks down the cell structure, and you've got this film, let's call it a plastic film, sitting on top, and as the cell structure breaks down, the foundation becomes weak underneath, and it starts to split and peel off. And can you imagine what a nightmare that is trying to fix peeling stain? So if you question why would I use a penetrating stain that only lasts a couple of years, or even brands talks about, well, it's easy because it just erodes away. There's no stress on the film pulling it because there's no film there, but you've got much more regular maintenance, but it's easy maintenance. Is that cool? So it's just be aware of what sort of stains they are. Yes, some of these are still available in the market, but that's what nature does. And also be aware of stains that come from Europe, and there's a lot of them coming in. Now, I'm not biased against that. What I'm biased against is Europe does not have the same level of ultraviolet radiation as New Zealand and Australia does. That hole in the ozone is still there. It might not be as bad, but we get a lot more radiation, hence why we get a lot more skin cancer in this neck of the world. And it's unfortunate, but that's from the ultraviolet radiation. So you see that orange ginger color there? They are transoxide yellow and red oxide pigments, which are very good at absorbing some UV, but some of it still makes its way through. So that's just a fact, and that's what it is. Now, you could polyurethane it. I strongly recommend you don't do that, because what happens is this. Now, remember we said about the film forming stain, and the UV goes through, breaks down the structure of the timber underneath, and then it all peels off. What do you think is going to happen with polyurethane? We do put UV absorbers in it for those yacht varnishes and those door varnishes, but do understand that this is what's going to happen, and it will happen, and then it's a lot of work to recoat it. Now, wouldn't you rather just to put a light colored penetrating stain or oil on that, and then just after a couple of years, just give it a clean and whack on another coat? It's so much more easier. If you're going to use polyurethanes, expect to put on 5 to 7 coats of a special yacht varnish or door varnish, and expect to have to strip it and totally redo it eventually. And if you see a lot of those super yachts and fancy boats, you'll notice a lot of their teak decking now, they either leave it natural to silver, or the ones that do polyurethane it. The bit you don't see, because you only go there for a party on the yacht, is you don't see when they have to maintain it and spend millions of dollars, upgrading those yachts. So just keep that in mind. I mean, I'm not doing a promotion. Resene does Altex yacht varnish. We sell it. It's double the price of normal varnish. You've got to put on 7 coats, and eventually this is going to happen. So it is just what clear coatings do on timber. I'm sorry, there's no magic bullet. And here's my favorite, solid paint. And it's like I say, but what we're actually doing here is the UV just bounces off, right? I'll show you some negative sides for paint in a second, because I'm going to be unbiased here. So when you think about paint, it's harder for the molecules of water to go through. They will go through, and the timber still expands and contracts, but they do it a lot slower than a stain, as an example. But it's not a big deal if you've got the right sort of timber that doesn't move very much, all right? But paints are solid, so they're just stopping the UV and slowing the water down. But let's look at some exposure breakdown on paints, just so you understand. And this is a classic design from the 1960s, and you see the weatherboards at the top are actually vertical, but then they come down in a curve. Now, this is the north face of this house, but as you can see, the boards at 90-degree angle are just fine, and then the ones that are at under 60-degree angle are cracking or flaking and peeling. And you think about it when you go out in the sun, at the top of your nose always gets sunburned, but your cheeks don't. It's because your nose is at a 45-degree, loosely speaking, angle to the sun, so it gets twice as much ultraviolet, so it burns a lot more. That's why cricketers put zinc on their nose. All right. So you can see there's a photo that was taken in Christchurch from one of our Resene guys, and it's an amazing photo to show you that as the angle changes, the exposure doubles, so you get less life out of that exposure. And let me convert that into a weatherboard for you. Seen that before? Does that look familiar? So there's your angle, and here is a rusticated weatherboard. And again, not picking on the weatherboard, I'm just showing you that you need to understand these things. And so you get less exposure and then high exposure as it curves down the bottom. But in fairness, the paint on this one, I know this weatherboard rather well, and the paint wasn't thick enough, and there's a whole lot of other reasons there. But you get a drip point right there where water, when it rains on the board, sits and waits to fall off. But as it's doing that, because when you painted it, paint was liquid and it has surface tension, it pulls back. The paint was thinner on that area. That's why we always say remove your sharp edges of your timber. So it's thinner, so there's less paint there in the first place. The water soaks in, it expands. The thinner paint can't move and expand as much, so it splits, and then the water gets in and expands it even more. And then, of course, the paint splits and more water gets underneath it, and then it gets right into the cell structure, comes back up and pushes even the primer off. So that's why the primer pops off. And then our friend, the mold, can grow. So that's just a classic example of why I prefer, myself, just personally, I prefer the bevel back type weatherboards, or your board and batten, or all of these sorts of ones, rather than this more traditional older shape one. And if you do use a rusticated weatherboard, just understand that just nip that edge with a bit of sandpaper and make sure you get good coatings on it. And trust me, that this job was half the thickness it was meant to be. So I'm not picking on the board, I'm just showing you what can go wrong. But now you understand that that gets twice as much exposure. There you go. And just for everybody that's watching and listening, we're almost finished. So just a couple more slides. That's cool. So that's a fascinating picture. Now this is my favorite picture. And again, I know this weatherboard off by heart. This has got a low sheen acrylic on it, not mine, but it's got my primer on it, and it's overseas somewhere. It's in Australia. And you can see that we're not talking this splitting on the sharp edge. We're talking the splitting down towards the bottom of the board. You can see that splitting there. So let's have a look at that a little bit closer. I can tell just by looking at this board, not being smart, but it's a flat sawn board. Okay, and there's just a picture of, say, a flat sawn board, and I'll put some arrows on it for you. That part there is the late wood grain. This part here is the early wood grain. Now remember, this paint is a thinner, half the thickness it's meant to be, so it's not helping in the situation here. And of course, the board got wet. It's a flat sawn board. It moved quite a bit, but up until now, we've been talking about the total movement of the board. Total movement. But do you not think that bits within that board have moved a little bit more than other parts of the board? And they have, so keep your eyes on the screen, because the entire board is moving, but the late wood moves a little bit, but the early wood moves a lot, and then you get those splits right there. So after everything you've learned today, you could just simply see what is causing those problems. But in fairness, if the paint was put on the right thickness and the right spreading rate, that would have been less of a problem. But these are the sorts of complaints we get, and we have to look into it. And once you understand the physics of something and how things react in different environments, then you understand what you can do about it to reduce those effects. So that's what's exciting about timber, is you can get it to work, and you can get it to work very, very well. And don't forget, it's a carbon sink, it's good for the environment, etc., etc. So I like timber, and it's just a matter of understanding. Now, I'm not doing an advert for brands. The reason I show you this is they have many, many books and information available that you should have in your office, in your design office, and read it and refer to it, etc., because it has a whole lot of generic data, as does Abodo have information as well. So I'm just showing, that's just a very short selection. By the way, I've got all of those books. So just saying that it's a tool that we're lucky to have in New Zealand, having the brand sort of organisation. So just very quickly, as we looked at inside the tree, we looked at softwoods and hardwoods, we looked at heartwood and sapwood, we looked at early wood and late wood, cutting log, timber movement, cell penetration, why we coat timber, bare timber exposure, options to coat, and effects of angle exposure, paint splitting, and some brands literature. So I'm hoping that it was worth spending your time watching it today, and that generically you just start to have a better understanding of things, so that when people like me talk to you or Abodo talks to you, you can start, when they start saying the reason thermally modified timber is more stable, it's because it's this and this and this, you might have a better understanding of just general timber itself, and then you start asking more questions of your timber suppliers and start understanding the environment it's going into. Over to you, Sarah.
That's great. Thank you, John. It's yeah, I think timber's really fascinating, and again, just to reiterate, it's a natural product, and as you said, we take the bark off, which is the protectant. So the weather gets it. Cladding doesn't come inside when it gets too hot or when there's a storm, or it's outside always. It goes through a lot through its lifetime. So, and I think expectations need to be understood. So I think, understanding this 101 of timber is just, it's excellent. It's excellent information, and I think really valuable. So yeah, I hope everyone here has learned something from here, because it's important from our point of view when we're selling and trying to set expectations. People want a natural look. There's an understanding as what that comes to. It's a paint finish is very different from a stain finish. So yeah, no, it's great. Just there's just a few other questions. Just two more questions here. A lot of people are saying thank you, brilliant presentation. So that's really great.
Thank you, everybody.
Stephen has asked, where does Danish oil fit in? Back when you're talking about the oil.
That's it. Thank you very much, and that's an excellent question. So you would have seen when I was covering the oils, one of them said Danske teak oil. Remember when I did that mold presentation, and I did the beer pine, and then the mineral oil, and then the Danske teak oil, and then the linseed oil. Danske teak oil and Danish oil are basically the same thing.
Okay. So you're saying appreciate it's a more internal use. So it's okay internally, it doesn't have the same mold growth scenario because you're not.
Unless it's in the damp back of a house somewhere. So remember, inside you get a much more drier environment. It's actually less mold spores. I'm just talking from nature, etc., etc. So absolutely no problem with that. And in fact, it makes the wood look beautiful. 2 seconds on this. The oil soaks into the timber, which allows the visible spectrum of the light to go further into the timber and refract and then absorb different light waves and then pick up more of the natural colors of the timber as the other bands of the light of the rainbow are bouncing out. So that's why the wood looks so beautiful on the inside. Just please don't use it outside, and then you'll be fine.
Yeah. Okay. And another one was referring to hardwood grappa decking, want to prevent it from silvering off. Obviously would need to put a pigment on. The question is a penetrating stain, is that the way to go?
So and again, and I'm not saying this for the sake of it, I'm saying that's an excellent question. So bear with me for 60 seconds. Remember, we showed you the difference between hardwoods and softwoods. And the hardwood is very, very, very dense. So if you put new hardwood down, it's going to silver off because that color gets washed out by nature, and it will get washed out by nature. The problem is if it's new and I put stain, and it will be penetrating, by the way, but it can't penetrate because the timber is so closed up that you'll put it on and it'll just wear away in a matter of a month. I'm sorry, but that's what happens. So the best thing you could do from a durability point of view for stains is if you put the decking down and then just leave it to weather for a while. You could pre-stain it and put it down and just leave it to weather for a while, and then the cells will break open a little bit. And then after 6 months or a year, you give it a clean and then put the stain, bring it back its color. That's why we put the pigments in the stain. Then you'll start getting a bit more durability. But with decks, because they're horizontal, you are talking about an annual restain. Just saying. So understanding that the density of the hardwood is just so hard for the stain just doesn't penetrate until it breaks open a bit with weathering. Personally, I like the silver look and I get it, but some people don't. And the reason they choose those beautiful hardwoods is for the color. But you need to understand there is nothing to stop weather washing that color away. Purple heart, green heart, they're amazing colors. Quila is even an amazing color. Some of these other colors, they will all go silver because that color washes away. And you need the stain to penetrate, and it just can't until the cells break open on that. So I'm sorry, but if the owner, the hardwood decks are long term, right? So, and I know we all want it for like $1 billion, but that's what's going to happen. So put it down, let it do its weathering thing, and then stain it to bring back the color and treat it that way. I really don't have more of an answer than that. Sorry.
Okay, awesome. All right. Well, thank you, John. Yeah, I think we'll leave it there. But that's yeah, great. Thank you, everyone, for participating in those questions. And John, thank you very much for this afternoon. Anyone on here, if there's any further questions you've got, look, fire them through at any time. We can more than happy to answer them, get back to you. If something else comes up after this. But this recording of this will also be available to you all fairly soon after we've wrapped up. So yeah,
Great.
There we go.
Thank you.
Thank you, John. All right. Have
Thanks,
a nice
everybody.
afternoon, everybody. Thanks for your time. Bye.
Bye.